Alright, here are our 5.6 notes, you guys, and we are going to deal with similarity properties. I'm specifically, you guys, working on dealing with proportions. Okay, so we have a couple different theorems here that we are going to identify and then do some problems with. So first we have what's called the triangle proportionality theorem, aka side splitter. We have the idea of similar right triangles, and then we have angle bisectors and a theorem involving them, and our triangles specifically again with similarity. So the first one, the triangle proportionality theorem, is the idea that if we know that DE is parallel to AC, then we know that the sides are proportional, which, as we reviewed a little bit in 5.5, means that if we put one side over the other, so if I put BD over DA, or a piece of the side over a piece of the side, then that would equal BE over EC. So if we know those lines are parallel, then we know that the pieces of the sides, side splitted, right, side splitter idea, we know that the pieces of the sides are proportional, meaning that if we set up the fractions are equal. And this theorem idea can go the other way too. But this one is if we know that the whole side, or I'm sorry, this is supposed to be BD. If we know that BD is BD over DA is proportional to BE over EC, then these sides are parallel. Okay, so that's our first idea. We're going to do some problems with that. Second idea is similar right triangles. And with similar right triangles, the idea here is that if we have a right triangle that is split into two other right triangles, so we have a left triangle and a right triangle, and we have a whole big triangle, okay, then each of these triangles would be similar to each other. So the whole triangle, the big triangle, ABC, would be similar, right, where B is our right angle there, that would be similar to triangle, and then we could list these in any order, but I'm going to go ahead and do my right, the medium size one, but I'm going to flip it so that it's oriented the same way as ABC was. So if I flip it, my right angle is D right here. My short side is from B to D, and my long side is from D to C. So it is similar to BDC. And just like congruence, we want to make sure that we put our letters in the right order of what they correspond to. And then my smallest triangle, that left triangle, would be ADB. A to D being my short side, D again being my right angle, and B being my long side. Okay, so if we have a right triangle that is split into two other right triangles, then all three of those triangles are similar. And then our last idea here, angle bisectors, is that if we have an angle bisector, so if BD is an angle bisector as marked on our picture here, then all of our sides are proportional. So BA over BC would be equal to AD over CD. So long over short equals long over short, or sorry, this one's long over long equals short over short. Or we can also write it as long BA over AD equals BC over CD. So we can either go long over long equals short over short, or long over short equals long over short. Okay, so we have those three ideas that we're going to use in these problems now. So on this first one, we have the side splitter theorem, right? We have a line segment going through our triangle. This is not a mid-segment because it does not split the sides in half, but it is parallel to our third side, which means that if we take 12 over 14, that would be equal to 15 over x. So we go piece over piece equals piece over piece. And then been a little bit since we've solved proportions, but to solve a proportion when you have a fraction equal to a fraction, we can shortcut it by cross multiplying. So we go 12 times x equals 14 times 15. So 12 times x equals 14 times 15. And this cross multiplication, guys, only works in problems like this, only works when we have a fraction equal to a fraction. So 12x equals 210. And when we divide both sides by 12, we get x equals 17.5. Okay, then our next problem is similar. You have parallel sides, so we know that our pieces would be proportional. So we can go x over 36 equals, and then what we need to make sure we do here is the whole thing is 55, but we only need the short piece, the piece that corresponds to the x on the other side. So that piece would be 10 over 45. And then again, only because it's a proportion, we're going to cross multiply. We get 45 times x equals 36 times 10, which is 360. And when we divide both by 45, we get x equals 8. So that's practice with that side splitter theorem, the first one we had. Second one here is the angle bisector theorem. Okay, so again, we're going to do either long over short equals long over short, or we can do long over long equals short over short. Either way, on this problem, we have that the whole side here is x, and then this piece of it is 12, which means that the other piece here would be x minus 12. So just like above, we had 55, this is the whole thing. We did 55 minus 45 to figure out that this was 10. This is x, the whole thing's x. So if this is 12, we have to go x minus 12 to find that piece. Okay, so then our proportion, we can set it up however we want, as long as the corresponding sides are in the correct location. So I'm going to go ahead and set it up like we did that first fraction above. So if we go 18 over 30, that would equal 12 over x minus 12. And then again, I'm going to cross multiply. I'm going to get 18 times x minus 12, and I need to make sure that both the x and the 12 get multiplied by 18 there. And then I have 30 times 12. So when I distribute the 18, I'm going to go ahead and move my work up here. I'm going to have 18x minus, whatever 18 times 12 is. 18 times 12 is 216. and that would be equal to 12 times 30, which is 360. Then I'm going to add 216 to both sides. 18x equals 576. Divide by 18, and I get that x equals 32. Okay, and then the next one, we'll go ahead and set it up like we did the second fraction up above under this angle bisector theorem. So one way we can do it, like we did there, is long over long equals short over short. Or we can do long over short. So if I do x over 36, then that has to equal 54 over 40. And then I'm actually going to go ahead and reduce this 54 over 40 to 27 over 20. So then I have x over 36 equals 27 over 20. That's just going to make my numbers a little smaller instead of multiplying by 54 and 40. Now I'm going to have 20 times x equals 27 times 36, which is 972, and divided by 20, that is 48.6. Okay, so there's the angle bisector theorem. We did the side splitter theorem, angle bisector theorem. Now I'm going to go ahead and go do this right triangle theorem so that we do one of each. Okay, so the right triangle theorem here is each of these right triangles is proportional, right? So I've got my triangle on the right, triangle on the left, and my big triangle. So that means that if I put so I'm actually going to go ahead and redraw my triangle on the right there. Okay, so this is my triangle on the right. There's my right angle. Okay, which means that my short side is the 8. I'm going to draw this a little bit better here. So actually I'll just draw it like this. Okay, my short side is 8 and my long side is 14. And then when I draw my triangle on the left, my short side is x and my long side is 8. So we want to make sure we identify what our corresponding sides are so that we can set up our proportions correctly. So again, if we do short over short equals, so I did x over 8 equals 8 over 14. Then I cross multiply and I get 14x equals 64. And then I divide 64 by 14. And 64 divided by 14 is not an even number or even a terminating decimal. So I'm actually just going to go ahead and reduce the fraction and then leave it as an unreduced fraction, because that will be a more accurate answer than rounding my decimal. Okay, so we have time for one more here. Let's go ahead and do this side splitter. So this side splitter, again, this is, we're going to be looking at our side splitter theorem up above theorem. So we're going to go one piece, whoops, not that, 3x plus 1 over x minus 1 equals 21 over 6. So then we're going to cross multiply, and we're going to get 21 times x minus 1 equals 6 times 3x plus 1. Then I distribute for each of those, and I get 21x minus 21 equals 18x plus 6. And then I'm going to move my x's to the same side and my numbers to the other side. So if I subtract 18x, I get 3x. My 21's cancel out. My 18x's cancel out, and I have 3x equals 27. Divide by 3, and I get x equals 9. Okay, now this would be a problem where we'd want to make sure we answer it fully. There's actually no instructions on here, but say it said find the measure of BD, right? Then we'd want to make sure that we plugged x back in to find the measure of BD. Okay, so just make sure that you double check that you answered the question correctly. And that will be it for our 5-6 notes.